This is a key to section 11.1 part B. So you're solving these quadratic equations, and notice that these are quadratic equations. If you were to uh, multiply these binomials out, the x minus 4 times x minus 4, x plus 5 times x plus 5, and so on, you would get a quadratic equation. It would be in the form ax squared plus bx plus c equals 0, sorry. But notice that these quadratic equations are in that particular form where you want to rewrite it as a algebraic expression containing the variable squared equal a number, where this is any real number. And notice that all these, at least these two, these 3 and 4 as well, are in that form. So remember, you want this to be a 1. So if you go back to the previous part A, you'll see what I'm referring to. So if it's not 1, you gotta get that to be a 1. All right. So if you notice that what's being squared is an algebraic expression. So right now I'm squaring it. The opposite of squaring is to take the square root. So we have x minus 4 squared equals 16. So if I take the square root of both sides, remember the plus or minus. We discussed the reason for plus or minus earlier. And so when you square, when you take the square root of an expression being squared, you're left with that base. So I get x minus 4 equal plus or minus 4. Now remember, 16 was a perfect square. So what you end up with is a rational number. So the square root of 16 is a rational number. When you get a rational number, the way I want you to write it is to rewrite it as with the solutions being rational. So you want your solutions to be rational numbers, be written as rational numbers. In order for that to happen, the best thing to do is to say, well, if x minus 4 equals plus or minus 4, then x minus 4 has to equal the positive 4, and then x minus 4 has to equal negative 4. And then you just solve each linear equation. So here you add 4 to both sides, so x equal 8. Here you add 4 to both sides, and you get x equal 0. And you can check each one just by looking at it. So if x is 8, 8 minus 4 is 4. 4 squared is 16. If x is 0, 0 minus 4 is a negative 4. Negative 4 times itself is 16. So both of those are solutions. So x equals 0, 8. Over here, when you take the square root of both sides, I'll go ahead and rewrite it. And don't forget the plus or minus. So the square and the square root undo each other. So you get x plus 5 equal plus or minus. Now remember in previous lessons that the square root of a negative 49 is a 7i. Now notice that this time you're going to get a complex number. So in that case, all you need to do is just get x by itself. So it's going to be written differently than this one. See, these were rational numbers. These are going to be complex numbers. And so 5 and negative 5 is 0. So you get x equal, negative 5 plus or minus 7i. So you leave your answer like this. Or in my math lab, they're going to want you to separate the solutions using commas. So you're going to say x equal negative 5 plus 7i, comma, negative 5 minus 7i. Okay, now number 3. You have, again, it's of that form. You want it of this particular form, which it is. So you have an algebraic expression squared equal a real number. And this right here is a 1. So when you rewrite it, and you take the square root of both sides. So the square and the square root undo each other. So you get x minus 7 equal plus or minus the square root of a negative 24. Now let's go right here and figure out what the square root of a negative 24 is. So just as before, I can rewrite this as negative 1 times 24. And 24, the largest perfect square that goes in 24 is 6. So since I don't have much room, I'll go ahead and rewrite it like this. So negative 1 times 4 times 6. And we know that the square root of a negative 1 is I. We know that the square root of 4 is 2. So I'm going to get 2i squared is 6. So that's what the that's what the square root of a negative 24 is equal to in terms of simplification. So here I'm going to get x minus 7 equals plus or minus 2I squared root of 6. Now just like with number 2, we had this complex number, you can go ahead and leave it like this, where you get the whole number part plus or minus the imaginary part. So I'm going to add 7 to both sides and then I'm done. So 7 and negative 7 is 0. So you get x equals 7 plus or minus 2I squared root of 6. So you can leave your answer like this, or you can write it as x equals 7 plus 2I squared root of 6, comma, 7 minus 2I squared root of 6. Okay, over here, again, you're going to take the square root of both sides. So this is a quadratic equation, and they want you to use the square root property. And it's of that form where you have an algebraic expression squared equal a real number, so it's easier to take the square root of both sides, plus or minus. And then the square and the square root undo each other, so you get 3x plus 2 equal plus or minus 8. Now notice, just like with number 1, remember 16 was a perfect square, so I got a rational number. So here's how you wanted to write the answers. When you got a complex number, this is how you want to write the answer, like this or like this. This is a rational number, so you're going to split it apart like this, just like you did number 1. So you're going to say 3x plus 2 equal 8. 3x plus 2 equals a negative 8. And then you're going to solve these linear equations for x. So subtract 2. I get 3x equals 6, so x is 2. Here, subtract 2. I get 3x equals a negative 10, so x is negative 10 thirds. Divide both sides by 3. And so your solutions are these two rational numbers, so x equals negative 10 thirds, comma, 2. All right, number 5. All right, so you have, again, it's of that form, so I can go ahead and take the square root of both sides. So I'm going to take the square root of both sides, don't forget the plus or minus. So the square and the square root undo each other. So you get 2x minus 3 equals plus or minus 5I. So again, we have a complex number. I'm going to add 3 to both sides. And so I'm going to combine like terms, that's 0. So I'm going to get 2x equals 3 plus or minus 5I. Now, remember, I got to get x by itself, so all I got to do now is divide both sides by 2, just like this. And so I get x equal 3 plus or minus 5I divided by 2. And always look and see these real number parts 3, 5, and 2. See if they're divisible. See if they have a common factor other than 1, and they don't. So there's your answer. So in my math lab, if you want to write it as, if they ask you to write it as two separate solutions, you're going to say 3 plus 5I over 2, comma 3 minus 5I over 2. And again, you can also write it as two separate fractions. You can say x equal 3 divided by 2 plus 5I divided by 2, comma 3 divided by 2, minus 5I divided by 2. Alright, so either one of these are all correct. Alright, over here, take the square root of both sides. We have the plus or minus. So I get 5x plus 3 equal plus or minus the square root of 32. Now let's figure out what the square root of 32 is. Okay, so it's not going to be complex because of that. I'm not going to square root of a negative number. So it's going to be a real solution. It's going to be irrational. Now, when I say it's not going to be complex, I should have said it's not going to contain the I, because all real numbers are complex numbers. But let's go ahead and rewrite this as a square root of 16 times 2. So that's 4 square root of 2. So that's going to go here. So you get 5x plus 3 equal plus or minus 4 square root of 2. Now notice this is 32 is not a perfect square, but I don't end up with an imaginary unit, imaginary number. I don't get an imaginary number here. So this is an irrational number. So whereas these were number 1, where these were rational numbers, where all these are rational numbers, this is irrational because of that square root of 2. There's no way you can write square root of 2 as a rational number. This is irrational. We talked about irrational versus rational in another lesson. So subtract 3 from both sides. I get 5x equal negative 3 plus or minus 4 square root of 2. Divide both sides by 5. I get x equal negative 3 plus or minus 4 square root of 2 over 5. And so there's your answer. Now again, always check and see if this negative 3, 4, and 5 can be reduced, and you can't. Now if you want to write it, if in MyMathLab they ask you to write it as two separate solutions, you're going to say negative 3 plus 4 square root of 2 over 5, comma, negative 3 minus 4 square root of 2 over 5. Okay, over here, again, take the square root of both sides, plus or minus. The square and the square root undo each other, so you get 4x minus 1 equal plus or minus. All right, let's figure out what the square root of negative 48 is. Let's see, 16 divided by 48 is 3. So I can write this as square root of negative 1 times 16 times 3. Square root of negative 1 is I. Square root of 16 is 4. And I'm left with the square root of 3. So that becomes 4i square root of 3. So that goes here, 4i square root of 3. And then just adding 1 to both sides, combine like terms, I get 4x equal 1 plus or minus 4i square root of 3. And then I'm going to go ahead and write this here. Okay, so now divide both sides by 4. I get x to be 1 plus or minus 4i square root of 3 over 4. Now don't make a mistake and divide out these 4s. You can't do that because this 4 is also being divided into this 1, so you got to be careful. So always look to see, can these three numbers, do they have anything common other than 1? And the answer is no. Again, don't make the mistake. This is a mistake. This is not true of saying this. You can't do that and say the answer is 1 plus or minus I square root of 3. That's not true. Okay, so don't make that mistake. Now, so again, you can leave your answer like this. Now, if you want to split it apart into two expressions, you can. You can say x equal 1 plus 4i square root of 3 over 4, comma, 1 minus 4i square root of 3 over 4. Now, let me say this. If you write it as two fractions, this idea about reducing could come into play. Watch how that looks. So remember a while ago we said we can't divide out these 4s because of this 1, because 4 has to be divided into this 1. But if you break it down to two fractions, notice what happens. You get 1 divided by 4 plus 4i square root of 3 over 4, comma, 1 divided by 4 minus 4i square root of 3 over 4. It can be nice like this. Now here you can reduce, so you can reduce those. So you can get 1/4 plus I square root of 3, comma, 1/4 minus, and remember these 4s you can reduce, so it'll be I square root of 3. Alright, so either one of these is fine. Any one of these. And then again over here you can write this as, just to let you know, you can write this as x equal 1 divided by 4 plus or minus 4i square root of 3 over 4. You can even go further and say 1 divided by 4 plus or minus, and these 4s divide out, I square root of 3. So either one of these are fine. So there are multiple ways of writing your solutions in each of these cases for that matter, except really for the rational. There's only one way to write the rational, negative 10 thirds, 2. Now you can write negative 10 thirds as a mixed number, but just leave it as an improper fraction. Okay, so that's going to take care of the key to section 11.1, part B.